Okay, so like I said, today we're going to start multiplying some polynomials, different things. I think you've already done things like 1, 2, and 3. Let's make sure we're solid though, because I don't think we are yet. So if we've got monomials times monomials, like we just did a second ago, you look at all the different things that are the same and multiply them. So if you want to write out an extra step, you can. So let me show you what step you can write if you really want to. Get your numbers together first. So what should I say is first? 6 times 9. I think this is kind of a waste of time. If you like it, do it. This is what I'm doing in my head, right? I'm looking at my numbers first. Then I say, what's my first variable? Well, this one just has y's, so I guess it's just y cubed and then y to the 8th. So if you want to write that step in, if that helps you, then by all means. What is 6 times 9, though? 54. So usually when I do it, I just go straight and say 54. And this one doesn't have lots of different variables, so also when I do it, I just say there's 3 y's, y, and then right next to it multiplied is y, 8 y's, yeah? So how many y's are there? So it's y to the 11th power. The exponent rule that we went over, the commandment of exponents, said if you had y's next to each other and then the same base, you add the exponents. 8 plus 3 is 11. But if you forget that rule, just think about how many are right there, and it's not a big deal, okay? So on this one then, you guys tell me, what should I do first?
3 times 9.
3 times 9, let's skip that. What is that? 27. And then we've got a variety of stuff, so I guess I'll take another step. So I'm going to write x, and then what am I going to write next? X squared. Nice, Colton. And then what am I going to write? And then, there we go. And now you've got everything right next to each other, comfy, cozy, so you can just say how many of them are really being multiplied. How many of the x's are really being multiplied there? There's 3. That doesn't mean it's 3x. 3x is triple x. X times x isn't triple x, it's something different. It's x cubed, right? So be careful with the language there a little bit. But and then this one, same base, add the exponents, 7th power. Or do it the other way. That's it. Any questions? So I'll give you another one of those to practice on your own in a second here, okay? So we can make sure we're all on the same page very quickly. Okay, this guy's not really a monomial times a monomial. What is it? Monomial times a binomial. There's 2 terms. So how do we do that? I think we kind of hinted at it only. Distribute, like this, right? Let's go ahead and do that. I'm going to go underneath here so we don't get too cluttered. So this is equal to what? So then do each one like the ones that we did up there. So I'm going to say 6 times 3 is 18. Using your fingers is, I think, also very helpful. How many p's?
2.
So p squared and a w. That's the first arc, right? Second arc is going to be these. So put your fingers up there if you need to. And we've got positive times negative is negative 12. Just 1 p this time. How many w's? W is w squared. Okay with that? And then you want to check real quick, are these like terms? They might be.
For $1 today only.
No, they're not. This is p squared, that's p's, that already screws it up. So they're separate, so that's all we can do. If they're like terms, smash them together. Okay? We did plenty of that. You guys seem pretty good at it on the quiz. So. All right, let's go ahead and look at number 4. Again, we've got a monomial times a binomial. Why don't you guys try that one yourself? I think that that's a good one to try yourself first. See what you get. I'll give you a second. Okay, so number 4. What's first?
Distribute.
Distribute, okay. I'm just going to have 2 distributes this time. Here, 6, because half of 12 is 6, right? Half times 12 is 6.
X cubed.
X cubed. Y squared. Done. Nice. That one's all done. And then what's next? Negative or positive?
Negative.
So positive times negative is negative. 13, yep. X to the 4th. Where are they getting their 4th from? Right here, right? And then also y to the 4th. Quick check, like terms or not? not, right? These are x cubed y squared things. These are x to the fourth y to the fourth things, totally different kinds of things. We can't put them together. Okay? So that's that one. Done. All right, number 5. This is very new. Maybe some of you might not be so new for. A couple people figured it out on the quiz. How do you do this? So some people learned about this quick cut thing, and it's called what? Foil. So foil's like first, outside, inside, last. It's just a way to remember stuff. It has a nice order to it, which doesn't matter at all. So I'm going to advise you not to use foil. Because look at this number 6. It doesn't work. So like FOIL fails after you get from binomial times binomial, so why would you bother learning it? If it helps you, great, but it also makes you remember things in order. There's no order that matters here, so why do that? You know what I mean? All you've got to do is take each thing, they're both in parentheses, so you've got to distribute everything by everything else. So first, if you want to write down an intermediate step, here's how you do it. So if you really want to write down a lot of steps and be extra cautious, I really need to take the x in this first quantity and multiply it by everything in that quantity. So if you want to write it, you could say x times everything in that quantity, right? And then I need to take the 4, the positive 4, and also multiply it by everything in that quantity. So you could say plus 4 times everything in that quantity. Isn't that how we write that down? And then it's just 2 distribute problems. So really this is just like double distributing. Okay, it's just distributing. If you think about it as something else, you're wasting your time and mental effort. You know, it's just double distributing, that's all it is. So go like this, and over here go like this, and you're done. So I've got, what's this times this? Squared, what's this times this? Negative, right?
No, negative 7.
Negative 7x, sorry. And then over here we've got 4x, and 4 times negative 7 is negative 28. And then, of course, like we always have done, you want to check, are there any like terms, anything we can put together, anything that's the same?
Negative 7x and 4x.
Yeah, these ones are clearly the same. So we've got 4 of them, we've got negative 7 of them. How many of them? Negative 3 of them. We're going to have negative 3 of the x's, and then these are by themselves, and so are the numbers. So that was the one just like number 4 on your quiz. There'll probably be one just like it tomorrow, or something very similar. Okay? It's just distributing everything by everything. So don't make it harder than it is. So number 6, FOIL won't work on this, but my strategy will. I need to distribute everything by everything. So you can take this first step if you want, or you can just start doing it. It's kind of up to you. I will say, you guys are going to take Park this year. Park has some hard problems on it. Park is going to have problems where if you don't know how to write this step down, you're not going to find the right multiple choice item, because they'll sometimes put it like this. And I will do that too on my exam. I might have multiple choice, and I might say, pick all the right answers. What is this equivalent to? You know what I mean? And one of the right answers will be the final answer, but another right answer might be that line right there. You know what I mean? So be cognizant of that, be aware. Havunagi, like we discussed the other day. All right, so if you want to skip that step, you can, by all means. We got to take x and multiply it by how many things? 3. 1, 2, 3. So this one is cubed. This one is
4x cubed.
4x cubed, because it's 1 times 4. X times x is x squared. Okay, so that's the middle one. You good, Sierra? We good? Any other questions? Joe, you good? So that's this one. Then this one is x times negative 6. So it's negative 6.
cubed. Wait,
No.
Just one x there, right?
No, never mind. Yeah.
Cool.
It's just like saying cubed.
Right, yeah. So there's only 3 of those. How many more do we have?
1.
Well, there's one more thing, but how many more terms are we going to get when we are done? 3 more. 2 things by 3 things, you should get 6 things. We've still got this one, and this one, and this one. Okay? So, this one. Minus 5x squared. Bolton's got this down. This one.
Minus 20x.
Negative 20x. This one, negative times negative, careful, positive 30. There you go. So this is one of those cases where if you're one of those people, like a couple people are in here still, you're resistant, you've got to write down the original problem, because eventually you need to be able to look at this and just know it's something like that. You might not know exactly what it is, but you should be linking this visually with this. Okay? So is there anything we can combine on this problem? The squareds and the regular x's? I think Richard's talking about these ones and these ones. Yeah? I like to circle stuff, but not so much stuff that it distracts my eyes. You've got to find a fit for you, all right? So x cubed by itself, how many x squareds do we have?
Negative.
Negative 1 of the x squareds, good. 4 minus 5. And the x's are all negative. How many of them? 26 of those. 30's by itself. So, the goal here is eventually to be able to link this and just know, hey, I'm going to get something that's cubic out of it. It's going to look something a little bit longer, or something like this. I don't know exactly what it's going to be, but I know it's going to be something like this. Okay. All right, number 7. I think that maybe this will be the last kind of problem we do for today. I'll leave everything else for tomorrow. There's a couple more things. Any ideas? How do we do number 7? So let me show you what not to do first. This is one of the worst mistakes you can make in all of algebra, because things like this come up all the time after this. Okay? So this is what some of my Algebra 2 students did at the beginning of this year, and it always happens every year. Some of the kids who took Algebra 1 didn't exactly learn how to do this. So they write things down like, well, I'd like distribute that, right? And I go like x squared, and then I square the 4. And the really bad mistake to make is to say, well, 4 squared is 16, so that's the answer, right? The problem is, we learned a rule that said you could distribute exponents, right? But I don't think that rule applied when there was a separator. That only applied to monomials. It did not apply to anything else with separators, like a plus or minus. So there's 2 big mistakes here. What's one of the mistakes? I bet you guys can tell me one of the mistakes.
One is the negative 16.
Negative 16, what should that be?
16.
16, why?
Because of negative times negative.
Negative squared, negative times negative is positive. There's one big mistake. There's still a huge other mistake here, and this is why I'm saying link it visually. There's stuff missing, and you should know that there's stuff missing. There's more stuff. How do you find the more stuff?
Isn't there an invisible one? And x raised to the power of 1.
Maybe. Maybe. I'm telling you, there's more stuff here. But you guys are like, well, I think we like squared everything, right? But you can't distribute this one.
Yeah.
So, let's start over.
X minus 4 times x minus 4.
Yes. Richard's saying, hey, that thing is squared, so that means really you're thinking about that thing times itself, right? That we're pretty, I think, sure about. Squared means thing times itself, right?
Yep.
Cubed means thing times itself 3 times. We'll do one with cubed tomorrow. So really, it's one of these problems, just like number 5. So then we've got to do it just like number 5. You've got to distribute this guy. Get x squared and minus 4x. And we've also got this guy, which is another minus 4x. And there's our positive 16. So we had some of it. We had the x squared and the 16, but we were missing other stuff.
You're missing 2.
And that's key. And if you're like, well, big deal, like I'm only missing some stuff, like that screws up everything later. So caution, okay? So how many x's do we really have that we were missing?
Negative 8.
Negative 8. So that's the real answer. Okay, so if you're watching the video, I think you want to try this one on your own. So see what you get when you square this binomial quantity. Just go ahead and pause it. All right, so first step, you guys, I think pretty much everybody had. Should write this down twice. Okay, Then we do double distributing, everything times everything. Now, whatever order is up to you. I mean, I always do it in a certain order, but you don't have to do that order. As long as you get everything times everything, you're good. So the first thing I do is these two, which is what? 9y squared. Those two are done. Now I'm going to go here. 18 of the y's, yep. And then here, another 18y. And then here, 36, like terms are in the middle. So that's 36 of the y's that we have total. So there's the expansion. So, last thing that I think I'll mention for today. I'll let you guys get started. For these things that are binomial squared, there's a shortcut formula, which I always use. I never do this. I always go straight from here to the answer. I don't waste time with that other stuff. I don't care if you use the shortcut formula or not, but I thought I'd show it to you in case you're interested. So look at number 7 and look at number 8 and tell me what's kind of the same about both of these problems. Can anybody see what's kind of the same? Probably a couple things are the same. Have a look. One sec, Richard. All right, what did you see that's the same, Richard?
Is always squared.
Okay.
The first number is always squared.
First thing's always squared. That's if you have to the second power, right? That's true. But if we raised it to the third power, the first thing would always be third power. Yeah, we'll look at that tomorrow. Okay. What else? What else is the same, Lindsay? And the binomials are always the same binomials. So what does that yield? What are the results of that fact that those are the same? Have a look here. Have a look here. It's this thing times this thing, and how many of those are there? This thing times this thing is that, and there's how many of those? That should lead you to a shortcut that you can do. So let me show you one last problem. I'll do this one quickly. So let's see, let's go 2x minus 8 quantity squared. Okay, so if we did it this long way, we'd go like this, right? You know what? Let me do it the short way first, and then we'll check it the long way. So short way is square the first thing. What's the first thing squared? Careful. What's the first thing all squared? 4 is 2 squared. X squared is x squared. What's the last thing squared? Positive 64. But I said it's a big mistake if you don't remember that there is more stuff. So what is that more stuff? Well, if you remember from a second ago, there were 2 of this times this. So that's the shortcut formula. When you get good at it, you don't even have to write it down. You can just be like, okay, first thing squared is 4x squared. Last thing squared is 64. 2 of that times that is negative 16x times 2 is negative 32x. And the answer comes immediately. So you're free to use the shortcut formula or not on your problems. If you do it the other way, remember you'd have to go like this, right? So you'd go write it down twice. That times that, that times that, that times that, that times that, like terms. Same thing.
Wouldn't it be plus 32x because it's negative?
A negative 16 and
Oh,
another
plus,
negative
that's
16,
right. I was
cumulatively we owe 32.
Okay.
Does that make sense?
Yeah.
Good question, though, sure. All right.